All right. So let's remind ourselves, right? The four steps in construct in working these word problems. Okay. What I think are the four steps. Right. Number one, draw a good picture. Okay. Visualization is very important. Right. Be able to visualize the problem. Number two, define your variables. Right? What does X mean? What does Y mean? And so forth. Represent. Set up the equation. Right? Which is your math model for the problem. And then number four, solve the equation. Which we don't put we're not putting a lot of emphasis on this, on number four, because the emphasis will be in calculus, calc 1. Okay. All right. So let's take a look at example number 4. A rectangle is inscribed in the parabola y equals 5 minus x squared, right? So you know how to graph a parabola. A is equal to -1, A is negative, so the parabola opens down. And the vertex is at the point 0, 5. Right, so here's the graph of the parabola. And so a rectangle is inscribed in the parabola y equals 5 minus x squared with the base on the x-axis, right? So the rectangle is above the x-axis and below the parabola. Okay? Right, the area A of the rectangle is a function of x. So here I've added some additional graphics. I chose an arbitrary point on the parabola and just drew a horizontal line segment. Okay. This horizontal line segment, right, is parallel to the x-axis. Now, where the line segment intersects the parabola right here, I labeled that point xy, right? The first coordinate for that point is x, and the second coordinate is y. And then I drew two vertical line segments, right, from the 2 points down to the x-axis. Now, this point, right, where the horizontal line segment and the parabola intersect, right, its coordinate is x. So the length of the rectangle from the origin to this point on the horizontal axis is x units. And because the symmetry, the axis of symmetry for this parabola is the y-axis, right? The distance from the origin to this point on the horizontal axis is also x units. So the total width of this rectangle is x plus x, or 2x units. Okay? Yes, sir.
Do we have to worry about absolute values with?
No, because we're dealing with x greater than 0. Okay? X greater than 0. Okay? That's the way I'm setting it up. Okay? X is greater than 0. So this is the point, see how I got labeled minus x?
Yeah.
So here where the vertical line segment crosses the horizontal axis at x. So then over here it's at minus x. Okay? And so I'm restricted x to be between 0 and this x and this intercept right here. Okay. The intercept right here is actually square root of 5. Okay. You can calculate the x-intercept by setting y equals 0 and solve for x. Okay. So the total width of the rectangle is x plus x, or 2x. The height of the rectangle, well, it's the value of y. Right, the y coordinate for this point. That's the value of y. And what's y equal to? Right, so you see how I got that drawn, right? Y is the height of the rectangle. And what is the value of y at that point? You get it from the equation of the parabola. It's equal to 5 minus x squared. So the area of the rectangle is 2x times y, where y is equal to 5 minus x squared. So for this problem, x is between 0 and square root of 5. Right? The parabola crosses the horizontal axis at square root of 5. Area of the rectangle is width times height. Okay, so I could have also done width times length, but when I was thinking in terms of width times height. Well, the width is 2 times x, and the height is y. So the area is 2xy. Well, y is equal to the height of the rectangle is equal to 5 minus x squared, whatever x is. So we can write area as a function of x, and it's equal to 2x times 5 minus x squared. So that's the area of the rectangle as a function of x. Okay? And then you'll use calculus in Math 120 to find the largest rectangle possible. The area of the largest rectangle possible. Okay? Any questions on that? Yes, sir.
Is that specifically for your drawn rectangle or square?
Well, that's an arbitrary rectangle,
Okay.
right? So this is the area of a rectangle inscribed by that parabola in the x-axis for all values of x between 0 and square root of 5.
Okay. Are you saying the one on the page is also arbitrary?
It doesn't look so arbitrary given that it goes from -1 to 1 in the base.
Yeah.
Right?
Mm-hmm.
Doesn't look so arbitrary. That's a specific rectangle. Okay? Where x is equal to 1. You understand what I'm saying?
Yeah.
And then you plug in 1 in for x, and you know what the area of that other rectangle is. Okay? But the one I drew is arbitrary. Right? X is any number between 0 and square root of 5. All right. You can calculate the area, right, for this rectangle here, right? You know what the width is, it's 2 units, right? And then to get the height of it, right, you put 1 in for x up here, and you get 5 minus 1 squared, which is 4. So the area of this one is 2 by 4, which is 8, right? 8 square units. And you should get the same thing if you plug in 1 in for x over here, right? 2 times 1 is 2. And you have 5 minus 1 squared is 4. 2 times 4 is 8. Okay. All right. Any other questions? Okay. So flip over your page. Example 5. A farmer with 700 feet of fencing wants to enclose a rectangular area and then divide it into 4 pens with fencing parallel to one side of the rectangle. What is the largest possible total area of the 4 pens? So what's step number 1? Draw a good picture. You gotta visualize this problem, right? So here is our rectangular area, okay, and the width of this rectangle, I'm going to label x as usual, and the length, I'm gonna label Y, okay? So X is the width. And Y is the length. Now, and divide it into 4 pins with fencing parallel to one side of the rectangle, right? So we're gonna divide this rectangular piece of area into 4 pins. So there's 1 pin, so 1, 2, so 1, 2, 3, 1, 2, 3, 4, okay? It just said divided into 4 pins. It didn't say equal size or anything. It just said 4 pins. Well, the width, right, this section of fencing is X feet long. So this section of fencing right here is also going to be X feet long. And this section of fencing is going to be X feet long. And this section of fencing is going to be X feet long. And then on the end here, that section of fencing is going to be X feet long, right? So we got 1, 2, 3, 4, 5 sections of fencing, all X feet long, okay? 2 sections to enclose the rectangular area, and then 3 more sections to divide the area into 4 pins, okay? And then the total length of the of the area, right, is Y units on top and bottom, right? All right. So the farmer has 750 feet of fencing. So we have a fencing constraint. The total length of fencing has to equal exactly 750 feet, right? So we got 1, 2, 3, 4, 5 sections of length X. And we got 1, 2 sections of fencing of length Y. And so those 7 sections of fencing have to add up to the fencing constraint of 750 feet of fencing, okay? So this is the fencing constraint. Okay? Those 5 sections of length X plus the 2 sections of length Y have to equal 750 feet. That's what the amount of fencing that's available. Well, we can solve for Y now, right? Subtract 2x or 5x from both sides. We have 2y is equal to 750 minus 5x. And now we divide both sides by 2. And we get y is equal to 375 minus 5 halves x. Okay, so far so good. All right, so what's the area of our rectangle? Well, area is width times length, right? Well, the width is x feet, and the length is y feet. So the total area of our rectangle is x times y. So substituting for y, we now can write the area as a function of x. What's y equal to? 375 minus 5 halves And now to simplify this, you distribute the x inside the parentheses. We have f of x is equal to 375x minus 5/2 x squared. So let's write this in ax squared plus bx plus c form. We have f of x is equal to minus 5/2 x squared plus 375x. So A in this case is minus 5/2, and B is 375, and C is 0, right? So this is a quadratic equation, right? Its graph is a parabola. Is the parabola open up or open down? Open down, right? So does that parabola have a maximum or a minimum? Maximum, right? So there's some value of x, right? There's some width for that rectangular piece of land that maximizes the area. Okay? So basically what we're going to do is we're going to find the vertex for this quadratic function. Okay? Find the x coordinate and the y coordinate for the vertex. All right. So x, right, at this vertex, xy, x is equal to negative b over 2a, right? That's the formula. Negative b in this case is minus 375, and 2 times a is 2 times minus 5/2, which is equal to minus 375 divided by negative 5. So what's x? X is equal to 75. 75 what? Feet, right? X is the width in feet. So with 750 feet of fencing, the optimal width for a rectangular piece of land is 75 feet. We're going to have 5 sections of fencing that's 75 feet. Okay. Can I erase this over here? What's y? The length? Well, y is equal to 375 minus 5/2 x. I think I just erased the calculation I did done previously. So we put in 75 in for x to get the optimal length. Okay? Did I make a mistake?
X minus 5/2 x squared.
Y is equal to 375 minus 5/2 x, right?
Where do you get 75?
X times y. This is x, and this is y. Then we distributed the x inside the parentheses. Right on?
Where do you get 75?
75 is the x value that we solved for, right? So that
Yeah.
looked at that picture.
Yep. This is the optimal width,
Oh, okay.
right?
Yeah.
The x is, we solve for x by finding the x coordinate of the vertex of the parabola. right? And so 75 feet is the optimal width for a rectangle. And once we know the optimal width, we just plug in for X to get the optimal length Y. Are you with me? And so what's the optimal length? 187.5 feet. Right? So here's the optimal width, and here's the optimal length for this problem. Okay? So what's the largest possible area with 750 feet of fencing? It has to be divided, this rectangular piece of land has to be divided up into 4 pins. The optimal area, right, which is X times Y, is equal to 75 times 187.5 feet, right? So you get the optimal, the maximum, right? The maximum area is equal to 14,062.5. You can write either square feet or feet square, however you were taught how to do it. And we're done. We solved the riddle. Okay. Farmer's got 750 feet of fencing, needs to enclose a rectangular area piece of land, divided into 4 pins. What's the optimal width? What's the optimal length? What's the maximum area? Yes, sir.
Could you also divide the rectangle in like a cross section?
Well, it says enclose a rectangle and then divide it into 4 pins with fencing parallel to one side. Okay. So that's a different problem. Okay. You could divide it into cross sections, but it's a different problem than what we saw. Okay. Yes, ma'am.
So for some reason I have remembered K equals 4AC minus B squared over.
Say that again, please.
I've remembered that K equals 4AC minus B squared over 4A.
Oh,
When I did
from when we
that-
completed the square, yeah, when we,
Yeah, when
Okay.
I did that, I got the maximum area, but I don't understand why, cause I thought.
because that is the Y coordinate, that formula.
But I thought that K equates to Y, so I don't understand. My brain is like, why would I not? I'm so confused. Maybe
Yeah.
later. Okay, never mind.
We can look at the notes
Okay.
from that section, right, after
Okay.
class. But, yeah, we'll look at the notes after the section. There's a logical explanation.
Okay.
All right, any other questions? Yes, ma'am.
So why is it that one up there squared?
Which one?
The y equals 375 minus 5 divided by 2x? Like why is it not the same as that?
Because that's what Y is equal to. Right, when we set up the fencing constraint, we set it up as 5x plus 2y is equal to 750. That was the fencing constraint, right? And when we solve for y, we got y is equal to 375 minus 5 halves x.
Oh, okay.
You guys are confusing y with x times y. This is x times y,
Okay.
not just y. Okay. Alright. Any other questions? Alright, so let's take a look at example 6. Similar problem. A rectangular plot of land will be fenced into 3 equal portions by 2 dividing fences parallel to 2 sides. The area to be enclosed is 1,000 meters squared. Express the total amount of fence as a function of the width x that would be required to build this lot. Okay? So again, let's go back and draw a good picture. So here's our rectangular piece of land, okay? And it's going to be fenced into 3 equal portions. So again, x is the width, y is the length, and then it's going to be fenced into 3 equal portions, okay? So we got 2 sections of fence in addition to the 2 end pieces. Now, if the total length is y, then each of these pins, their length is y over 3. Personally, I don't think it matters where you put these 2 sections of fence. Okay. Because what matters is the total area of the plot of land. Okay. So over here, you were given total fencing is 750 feet, and you had to find the largest possible area. Here the area is fixed, and now we want to find the least amount of fencing to enclose that. Okay? Alright. So again, x is width. And y is length for a rectangular plot of land. Okay. Area is width times length. The area is 1,000 meters squared. The width is x. The length is y, right? So this is the area constraint that we're given. So you divide both sides by x, solve for y, you have y is equal to 1,000 over x. So what's the total amount of fencing that we need in terms of x and y? Well, we got 4 sections of length x, 1, 2, 3, 4. And we have 2 sections of length y, top and bottom. So replacing y with 1,000 over x, we can now write the amount of fencing needed as 4x plus 2 times 1,000 over x. And 2 times 1,000 is 2,000. done. Now we use calculus to find the optimal width x. Okay. Okay. Any questions on that one? In example 7, express the distance from a point xy on the graph of y equals 3 minus 2 squared to the point 0, 2 as a function of x. Alright, so y equals 3 minus 2x squared is a quadratic equation, and its graph is a parabola. So let's draw that parabola. And so, you know, A is equal to minus 2 in this case, B is 0, right? C is 3. And so the vertex is on the y-axis at the point 0, 3. And A is negative, so the parabola opens down. So it's symmetric to the y-axis, okay? And we have the point 0, 2 on the y-axis. And we gotta take an arbitrary point on the parabola. So here I'm gonna take this arbitrary point right here. Label it xy. Okay. And you gotta express the distance from a point xy on the graph of this quadratic equation to the point 0, 2 as a function of x. So we have to use the distance formula. Remember the distance formula? Okay. We calculate the distance from this point xy to the point 0, 2, right, on the y-axis. So the distance from the point xy to the point 0, 2 on the y-axis is equal to the square root of x minus 0 squared, right? Difference in the first coordinates, x minus 0 squared, plus y minus 2 squared. Right, y minus 2 is the difference in the second coordinates. Okay. So this is the distance using the distance formula. Exam 1 material. Okay. Well, we know what y is equal to. Y is equal to 3 minus 2x squared, right? For a given value of x, y is equal to 3 minus 2x squared. So we replace y with 3 minus 2x squared, and now we have the distance between the point xy and the point 0, 2 as a function of x. X minus 0 is x, so we end up with x squared. And replace y with 3 minus 2x squared. And then we got to remember to subtract 2 from that. And then we're squaring that. So what's inside parentheses here? 3 minus 2 is 1. So we end up with 1 minus 2x squared quantity squared. And I stop right there. We have written the distance between the point xy and the point 0, 2 as a function of x. Okay? Doesn't say to simplify, doesn't say to expand, it just says to write it as a function of x. And we've done that now, right? So for any point on the parabola, xy, that's the distance between that point and the point 0, 2 on the y-axis. Okay? Are you with me? Okay. Number 8. And a wooden rectangular box with a square base of length x and height h is to have a volume of 32,000 centimeters cubed. Okay. So it's going to have a square base. Right? And so we will let x, right, equal the length. What they use the word length instead of width, right? So x is the length in the square base, and then one side of the rectangular box, right, will have a length of x and a height of h. Okay. This is one side, and it has an open top. Okay. So x is the length, and h is the height. So the volume for our rectangular box is length times length times height. Okay? Well, the length is x. We have x times x times h. And so the volume is fixed at 32,000 centimeters cubed. And we have 32,000 is equal to x squared times h. So that's the volume constraint. And when we solve for h, we get h is equal to 32,000 over x squared. Right? So whatever the width x is, h is restricted to 32,000 over x squared. Okay? So the area of the base of our box, you know, is equal to x times x, or x squared. The area of one side of our box is equal to, right, height times, okay, h times x. And so the total area for the base plus the four sides is equal to x squared plus 4hx. Right? There are four sides. It's area h times x. So 4 sides of h times x is 4hx, right? So there are 4 sides. Well, S of x represents total area, right? So S of x is equal to x squared plus 4 times h, where h is 32,000 over x squared, and then that's multiplied by x. So when you simplify that last term, you get the total area, S of x is equal to x squared plus 128,000 over x. Okay. So that's the amount of wood required to make the box as a function of length of a side of the base, x. Okay? And we're done. So this homework, you don't need to know the last example to do the homework. So this homework is due Monday night. Okay? So I'll see you Monday. Have a great weekend.